morning all of you. I am Tanushri Dalai from Civil Engineering branch. So today we will discuss the bending moment calculation of the cantilever beam having UDL on all over the span. So in the last class we already discussed about the shear force calculation and how to draw the shear force diagram according to the shear force calculation we studied already. And today we will study about the bending moment calculation, and according to that we will draw the bending moment diagram. Okay. So comes to the bending moment calculation. So one thing you have to remember, in case of bending moment calculation, you need to put a formula like you can see here. To calculate the bending moment in a cantilever beam having UDL, that means it is applicable for the UDL case only. So here what you will do to calculate the bending moment, you have to put a formula which is load into span by 2. And here the half of the span considered as perpendicular distance of the load. That means in case of bending moment calculation, we need to put W into length by 2. The length by 2 we multiply because this L by 2 is the perpendicular distance of the load. So in that way you have to put the formula according to the loading condition, that is UDL. So your first case is in case of UDL, while L equal to X, that means this case only. In second case is similar to shear force, which is length equal to L. So when L equal to X, that means the distance from the free end of the cantilever to the cut section of the cantilever. So the distance should be X. Then bending moment at XX section is, according to this formula, load which is W is given into distance which is X is given. Then another thing is the perpendicular distance of the load. So your load is in this way, that means in downward direction or vertical. Then the perpendicular distance should be always occur at the half of the span that you have considered. That means if we consider the distance X from here to here, then the perpendicular distance should be X by 2. Okay. So whatever you distance take, you have to put half of the distance as the perpendicular distance. Okay. So in that way we have to take load, that is W, into distance, that is X, multiply with perpendicular distance, that is X by 2. So as total your value should be W into X by 2. And because the loading system is at the right side of the section, so it will give this kind of moment in this direction, which is a hogging moment towards the cut section. So that here the bending moment value is in negative in nature. So you can see the total value of the bending moment at XX section or at cut section is W into X into X by 2, that is WX square by 2, and you need to put a negative sign due to hogging moment. Okay. So this is all about your when length equal to X. Again the case 2, that is when length equal to L. That means we have to consider from the free end of the beam to the fixed end of the beam. Or you can say we have to calculate the total span of the beam. So now you have to consider the section should be here. That means at the fixed end of the cantilever, the section should be here. Then we calculate this portion of the beam. So here the loading condition is same, which is W Newton per meter, and the length should be L. And I told you whenever you multiply the perpendicular distance, it should be the required length divided by 2. So the perpendicular distance for the whole span should be L by 2. So if we put the formula, which is load into span by 2, then we have to put load, that is W, span, that is L, and your perpendicular distance is L by 2 for total span of the beam. But in case 1, we took this distance only. So according to this distance, your perpendicular distance is this span divided by 2, which is X by 2. But in case 2, we consider total distance of the beam, which is L. So your perpendicular distance should be L by 2. So in that way, the bending moment at fixed end, while your length equal to L should be W into L into perpendicular distance, that is L by 2, is your bending moment value for fixed end support or at point A. So here also, if we consider this is the section, then at the right of the section, the load we considered. So this kind of load will give a moment, this kind of moment it will give. That means it will give a hogging moment towards the section which is here, so that the bending moment value should be negative in nature. So here we put the negative sign and the value is W into L by 2. As a whole, it will give minus WL square by 2. And minus sign detect the hogging moment of the loading system over the cantilever beam. So now comes to the bending moment diagram. So first one is your B point, at which only load is there but distance is neglected. So here only load is provided, that means at that point, but there is no distance, so that here your bending moment will 0. Then comes to the section XX point, that means here. So we got the value WX square by 2. So because your bending moment diagram is negative in nature, so that we draw a reference line here, which you can see at the upper side of the section. We need to draw a reference line. Then the point of the bending moment we should detect at the lower part of the reference line. So here we will get a point of bending moment, which is the point of bending moment for XX section. Then this point detect the Wx square by 2 value. Then for case 2, that is at the fixed end support, the value of bending moment is WL square by 2. So we got the value and detect the point over here. Okay. So now just joint these points with each other and joint all the points to the reference line. Hence, your bending moment diagram is completed. So in this way, your shear force and bending moment calculation of cantilever beam having uniformly distributed load is finished, and you know about how to draw the shear force diagram and bending moment diagram while it is the case of UDL. So today this much. We will discuss some numericals in the next class. Thank you.